Hi, everyone. We're live now. Welcome to this webinar sponsored by the Journal of Cognition. I'm Candice Mori. I'm a senior lecturer at Cardiff University and editor-in-chief of which is the Journal of Cognition, which is the official journal of the European Society for Cognitive Psychology. So we're here today because out of necessity, we've been blocked from our campuses and laboratories, forced by circumstances to take a pause and consider how we want to work going forward. So many of us are probably unused to remote working, at least to the degree we do it now, and we're discovering just how annoying and inconvenient proprietary software can be. So we might be considering whether we might want to be able to conduct novel experimental research online, how best to work that. Suddenly, we've got some leisure to consider choices that we would usually rush in the interest of quickly acquiring data. For me, that's a silver lining of this involuntary pause in data collection. I think data collection is so important, so time-consuming, and so resource-heavy that we really shouldn't rush it. This pause may be the opportunity we needed to make sure that our experimental practice is not just sound, but maximally useful for our colleagues and for our future selves. So for me, openly available software is a vital research tool. I want to be able to freely share experimental software I create with students and colleagues without fussing about licenses and without worry that the software that was in vogue when I was collecting data now will be obsolete in 10 years. If I spent time grappling over how to solve some problem, I want that effort to benefit my students and collaborators in the future. Fortunately, there are several brilliant openly available options for building experiments. They differ in their look and feel, in the language behind them, how they interact with peripheral equipment, how they may be deployed online, and there are good reasons why you might adopt any of these openly available platforms, depending on which features are most important for your project. Adopting any of them, compared with using proprietary software, will save you time in the long run and is likely to magnify the effort that you put into making a nice experimental program because it will be useful to a larger number of your colleagues now and in the future. So since work shifted from campuses to our homes, I've seen many people on social media wondering where to start with learning new experimental software, wondering which platform they use, what additional skills will be handy for using it, how can they find useful resources to jumpstart learning? These are really good questions. So today I've gathered 3 experts in different open platforms to help you navigate them. We've got Sebastiaan Mathôt for OpenSesame, Jon Peirce for PsychoPy, and Claudia von Bastian for Tatool. And they're all here to summarize the features of the platforms that they use and point you toward resources for learning how to use them yourselves. Before I hand over to them, I'll just briefly explain how interaction is going to work in this webinar. So each of the speakers is going to introduce and demo their software for about 10 minutes. After all 3 are finished, we'll be able to take some questions for our remaining time. So I encourage you during the talks to pose questions in the live event Q&A channel. I'll be monitoring that channel and compiling questions to ask the presenters later. So if you've got a question about a specific platform, that's okay. If you've got questions comparing one to the other, that's also okay. Post whatever is interesting you in the Q&A channel, and I'll do my best to compile and represent what you're asking. Okay, so I think now it's time to start with our first presentation. We're going to start with Sebastiaan Mathôt and OpenSesame. Sebastiaan, here you go.
All right, thank you, Candice.
You are. Okay.
All right. Am I visible?
I think you're live now.
Okay, very good. And if not, I'm sure the audience will. So here's my opening slide. I'm Sebastiaan Mathôt. I'm the lead developer and the manager of OpenSesame. And let's first things first, what is OpenSesame? OpenSesame is a free program, open source program for developing and running psychology and neuroscience experiments and experiments in experimental economics. And you can run behavioral experiments, so key press, reaction time experiments, but also connect things to EEG or eye tracking or fMRI. And I think that's especially relevant now in the current corona situation, you can also run experiments online. So what I'm going to do is give you a brief idea of the workflow in OpenSesame, going from opening an experiment through the Open Science framework, running it on the browser, running it on the web, and then showing how you can upload it to a tool called Yatos for deploying the experiment online. And this will go pretty fast. I'm not going to give you a tutorial. This is just to give you an idea of how the workflow works and to point you in the right direction. So let's start with an introduction. So what you're seeing here, so the first thing you need to do is, of course, download OpenSesame. So you go to osdoc.coxsci.nl, the OpenSesame documentation site, and there you will find the download button. You can click on the download button, and you will find that you can download OpenSesame for various operating systems, Windows, Mac OS, Ubuntu, etc. You're going to forget the exact link, of course. So what you can also can do is just Google for OpenSesame. Then the first thing that you will find is an e-learning website, OpenSesame. That's not us. But the second link that you will find is the documentation site, so you will find it there. And to me, a very big personal victory is that when you look at the videos, actually the #1 video for the keyword OpenSesame is the tutorial, and Leila K with OpenSesame, the music video, is only second. So I think that's already a very big accomplishment. All right. Now, assuming that you've installed OpenSesame on Windows, what do you get? So let me navigate. I've installed OpenSesame here, of course. And then you go down, and then up here in the OpenSesame menu, you see that you get OpenSesame, the software itself. But very importantly, you also get some other things, just like IPython, an interactive Python terminal. You get PsychoPy is bundled with OpenSesame. Jon Peirce will tell you more about that. Rapunzel, a code editor that is based on OpenSesame. But the most important thing for this purpose is, of course, OpenSesame itself, the experiment builder. So I will start that. Now, and then when OpenSesame starts, so I'm doing all of this live, so you can actually see that it works. You get this kind of overview. There's lots of buttons, and all of these things are explained in the tutorial that you can find online and in the documentation. So I'm not going into that. What I want to show you is how you can download an experiment from the OSF, from the Open Science framework. So here at the top of OpenSesame, you will see a login button, and the login button logs in to the Open Science framework. Okay. Then I already logged in, so now it's not asking for my credentials, but normally it would ask you for your login name, and then you would type that in. Then it will ask you if you want OpenSesame to grant access for OpenSesame to the OSF. You say, okay, allow. Then it will log in, and then you say, okay, show Explorer, and then you get a list of all the projects that you have on the Open Science framework. And I know, of course, my project, so let me try to find one. I'll search for the keyword color, and here we have the role of color categories in memory, working memory, very cool working memory experiment that we're doing now. And I'm just going to open that straight from the Open Science framework in OpenSesame by double-clicking on it, up, and up. I save it in the downloads folder. There we go. All right, so you see this is very nice. And the thing is also that it is linked to the Open Science framework. So when I make changes to the experiment, oh, I don't want to update it. When I make changes to the experiment and save it, I will also save the version on the Open Science framework, and it will remember all the old versions, etc. So that's very powerful, and it makes sure that you never lose track of the latest version of your experiment. So let me tell you a little bit about this example experiment. So what we're looking at now is an experiment that is a typical working memory experiment. On the left-hand side, you have the structure of the experiment. You see it's pretty complicated. It's all graphical, right? It's kind of OpenSesame sort of intermediate between PowerPoint and a programming language, you could say. You can do a lot of things visually, and then you can add programming code, either in Python code for the desktop or JavaScript code for the web, to sort of add more flexibility to your experiment. I'm not going to show you exactly how that works. I don't have time for that, but you can find all of that in the documentation and on the tutorials. So what I do want to show you, actually here you see with backend, you see that it currently has Psycho selected, meaning that right now this experiment will use the functionality from PsychoPy to run this experiment on the desktop. Jon Peirce will tell you more about PsychoPy. Now let's give this experiment a run. I click on the quick run, just to give you some idea of how this works. And now I'm running the experiment on the desktop and not in the web. I will show you later how you can run the exact same experiment on the web. But right now we're running it traditionally as you would in a lab on the desktop. Oh, So we're asking for the SONA ID, sort of the participant ID. Return. Okay, return. We get some explanation, instructions. The task in this experiment, you don't have to do, you know how the experiment works. I just want to give you some idea that you can implement very complicated experiments this way. You have to click on the target with the vertical line. Then you get some feedback. These are all the instructions. All right, another example. And then later participants have to recall a color that they had to memorize by clicking on the color circle. This is pretty complicated, right? And you can do all of this also on the web. So let's see how that works. I have to memorize this color, click on the target, correct, recall the color, and then the participant gets some feedback, new color, click on the target, report that color, etc., etc. Right? Pretty simple experiment. Okay, I press escape. Escape, quit to quit. And now I'm going to launch the same experiment in a browser by clicking on this test in browser button right here. What this will do is actually launch the experiment in Google Chrome in this case, which is my default browser. And then you will see that it's the exact same experiment. The only difference is now it is running in the browser window. So that's pretty cool, right? Because you can do the exact same thing. Including pretty complicated things like the color circle, etc. It's all supported in the browser. Okay, memorize this color, click on the target, and recall it. Right? Okay, so now you see this is pretty cool. But what we're doing now, if you look at the address here in the toolbar, you will see that this is actually running on my own computer. So it is running in a browser, yes. But that doesn't mean that it's online. It is running in a browser, but based on a file that is actually on this computer. So what we want to do, of course, is run it in a browser, but through a server that gives us a link that we can give to participants. So how can we do that? Well, we can do that too with OpenSesame. So I'll switch back to the software. And then under Tools, you will find an OS Web button. I'll click on that. And there you see a bunch of options. And one of the options that we see is that you can export the experiment as a YATL study. And there's a series of video tutorials on my YouTube channel that will tell you in a lot of detail how this exactly works. But for now, all I want to say is that this allows you to bundle the experiment in such a way that you can upload it to a server that I will show you. And through that server, you can generate links. And those links you can send to participants or put on Prolific or put on Mechanical Turk, etc. So export experiment as YATL study. I will save it in the downloads. It will save that experiment successfully exported. It will save that experiment in a particular format, a zip file, that if I go to YATLs, and my YATL server is yatls.coxi.nl. YATLs is an open source server that allows you to distribute links. But you do require access to a server that has YATLs installed. There's no such thing as a central YATL server that you can just use. You or your institution need to install that for you. Okay, I have one on my Coxi website. And I will log in. Type everything correctly. And there you see that on the left-hand side, now I'm logged into the system. On the left-hand side, I have a lot of experiments. And what I'm going to do now is say import study. I will navigate to my download folder, and it will say, okay, the gradual color matches to stim osx.zip. That's the one that I want. I open it. That's the file that I just exported from OpenSesame. I will import it into YATLs. I say import, right? And now it will actually appear here. There's actually two versions because I already did this before. I click on it, and now, and this is very cool. Here you can find all the documentation about YATLs on the YATLs site. YATLs is not developed by us, it's a separate project. And here you can get a link, get link. This is a very simple link. You can copy it and you just give it to your participants and you will collect data that way. So I will paste it here and then you will see that it will launch the experiment. It will look the same as before, but actually this time it is actually running online through a link that you can distribute to your participants. And the data will be logged in YATLs. What does it look when the data is logged? What does it look like when the data is logged? Well, let's go to another experiment where we actually have data already. This experiment, of course, I just uploaded, so it doesn't have any data. But here on the left-hand side, I have a gazillion experiments. And the color memory for OS Web, new version, I know has a lot of data. So I click on that. Here you see results, 62. I click on that, and then you get an overview of all the results that have been collected and their status, like did the participant finish the experiment, what did it fail for some reason, was it successfully finished, etc., etc. And then you can export those results if you want. Now, I think I'm already reaching my 10 minutes that I'm supposed to have to give you an introduction to OpenSesame. But what have I shown you? I forgot actually my slides, right? I got stamps. I bought stamps just for this purpose, just to make nice slides. So Yatos, right? So what did I show you? I showed you can download OpenSesame for free for Mac OS, Windows, or Ubuntu, or other operating systems to the extent that they exist. You can save your experiments on the Open Science Framework, download them, synchronize it with the Open Science Framework. You can run experiments on the desktop if you're doing it in the lab, or you can run experiments on the web through a system called OS Web. And when you do that, the system, you need another system that manages the experiment, that gives you links, etc., etc. And that system is called Yatos. And you can find documentation for all of this and examples for all of this and tutorials on the OpenSesame documentation or the Yatos documentation. And Google will point you in the right direction. All right, thank you very much. That's it. That's my pitch. I don't hear you, Candice.
I'm coming.
Ah.
Okay. Hey, all right. Thank you very much, Sebastian.
You're welcome.
That was fantastic.
Can I say that you actually have an amazingly comfortable chair? The way that it looks amazing. It's huge. Yeah. I'm jealous, actually.
It's pretty good. Yeah. Okay. So thanks very much for that. Please keep your questions coming in the Q&A. I'm compiling information about those. Next, we'll continue with another Python-based system and introduce Jon Peirce of PsychoPy. Hang on. One moment. There we go. And okay. All right, Jon.
Hi.
Here you go.
Hi.
Hang on one sec. Takes a minute. All right, here you are. You're live now.
Okay, hello. Thank you very much, Candice, for organising this, and hope people are looking forward to finding out lots of different things. I'm not going to take the same approach as Sebastian of sort of running a high-speed tutorial. I'm going to just try and explain some of the advantages of PsychoPy, and I'm going to fit it around this mantra that we have of trying to make a single package that's precise enough for psychophysics, easy enough for teaching, flexible enough for everything else. And I'm going to just step through each of those things and ask about whether or not we're meeting that aim. Being precise enough for psychophysics is something that we should manage. That's my background. I come from visual neuroscience, and I started writing PsychoPy back in 2002 as a toolbox to help me do my own study. So I'm not going to go into very much about that. A lot of people would ask about timing. So in particular, does PsychoPy have precise timing? And we've recently gone above and beyond in trying to measure that and quantify, well, rather than just saying, yes, we have sub-millisecond timing. Sub-millisecond precision is what you'll hear from a lot of people. We've actually now got a measure for PsychoPy, Psych Toolbox, OpenSesame, and a number of other packages, 10 in total. The quality of the timing in precision and absolute lag in various domains, so reaction times here, visual onsets, audio onsets, and many other things. And we've now published that. So if you Google for timing mega study, you'll find our paper on this as a preprint so far, and you can find the data online. I'm sure we're going to be sharing these slides later, so you'll get to see those links as well. Basically, the timing is very, very good. So if you've been using ePrime or presentation so far, you can switch to PsychoPy and you can get the same sort of levels of timing precision, is the take-home message. Is it easy enough for teaching? I'd say very strongly the answer is yes. PsychoPy is used for teaching in undergraduate labs and groups all over the world. We have a different layout to ePrime and OpenSesame. We sort of structure things in terms of the temporal layout. So here you'll see the graphical interface of PsychoPy, the builder, and you'll see we have routines, so this is a trial in this case, but you have other routines, maybe for your instructions or your thanks or your feedback. And you can see within this trial, we have a fixation. This is the nav on task. So it's present a stimulus, very briefly, cover it with a mask. And you can see in this trial that we've got a fixation point that lasts for the duration of the trial. At 2 seconds, we'll very briefly present a stimulus and we'll cover it with a mask. And the subject can respond from the moment that the stimulus comes on for the rest of that period. Now with ePrime, that would be sort of a slide for fixation, followed by a slide for fixate and stimulus with a response, followed by a slide for fixate and mask, followed by another slide for fixate. And your response, you would have to sort of sum up all of those various different segments, right? So I think you can see visually, it's just very intuitive to see what's going on. And you can also combine multiple routines in a flow diagram at the bottom. So here we've got instructions for the practice, then we've got a block design, the way I've set this one up. So we've got some blocks. Each block has more instructions and then some trials, and then go around from the next block. And at the end, we say thanks. Always nice to say thanks. I'm not going to try and explain to you how to do all of that, but you know, it's visually intuitive. It's relatively easy. There's a YouTube tutorial. In fact, there are lots of YouTube tutorials. But if you go and search for the Posner task for PsychoPy, you will find that, and that's sort of a 15-minute tutorial, including analysis. To support your learning here, there are a lot of materials online and in print, so we've actually got a textbook, which is unusual, I guess, for these sorts of things. Lots of tutorials that you can search for there. There's a forum with over 4,500 members, and we run workshops as well. So we could do a free afternoon workshop for your department, or we run sort of multi-day workshops that you then have to pay for to come along. But we run various levels of intensive training. And there are thousands of studies on pavlovia.org, which I'm going to get to, and several hundred more on the open science framework that Sebastian was just talking about. Okay, easy, precise. Is it flexible? PsychoPy can really do anything. As well as that builder, which already on its own is very flexible. You can insert code snippets where you can run arbitrary Python or JavaScript code, and with those, you can really do anything you like. You can interact with lots of different hardware. You can interact with, you can push studies online, which we'll come to in a moment. And we can also make stimuli dynamic and interactive. I'm just gonna show you a quick demo of what I mean by that. So these are stimuli that can change on every screen refresh throughout your study, throughout your trial. So you can make stimuli that respond to the participant and change during a trial. Let me just fetch you a quick demo of what I mean here. So here's a dynamic stimulus. I mean, this what I'm about to show you. This was created without any code. This is purely created in the builder. So we want to click the mouse to get started. We've got to find the ball. And when I click the mouse, it might be a bit laggy because we've got lots of, oh, there's the ball. I'm just moving the mouse around and using that to search, okay? The point is that we can create, and this is a demo of what's actually happening. All I'm doing is setting the position of a stimulus to be based on where the mouse is. And you can imagine that that might be based on eye position instead. And then on each trial, I change the image that's behind that mask. You can create studies, essentially, that are much more interesting than present an image, get a response, present an image, get a response. We're trying to break the mold of what a study can be. And these studies can run online as well. So even those highly dynamic interactive displays, let me just click on this link here. Or in fact, we can go back to, we could take that same study that I was just running and run it in the browser. I'm loading it twice now. And here we go and find the exact same study now running in Pavlovia. So we can, oops. Again, looking at exactly the same images and moving our mouse around. And this was the version to show you how it was working. Okay. That's done with just a couple of clicks. Rather than Yatos, we use our own server, so you don't have to worry about installing the server. We've got that built for you. It's called Pavlovia. You can use that to share studies as well, like Open Science Framework, without even needing, even if you're not planning to run online. And you can synchronize your data. You just go to your builder experiment and you press sync. Let me go and quickly find that. So here's my builder study of that task. By the way that I made that move, I just click on the image aperture here, and we can see a dialog box that says position is mouse get pos set every frame. That's how easy it was to move my image based on the position of my mouse. Now here we've got sync with web. I push that button and I get all of the trials that have recently been run from participants in my web experiment. So it's really, really easy. If I want to run online, I just click the run online button and we're pretty much good to go. You can also search Pavlovia. So we've got 6,500 users and over 14,000 projects online. Let me just show you that. I'm just going to, we could search in the web interface, but I can search directly here. So let's imagine we want a memory task. Search, there we go. Whole load of different tasks that people have uploaded and made public that I can now select one, fork it and sync with my local desktop so I can go and run a study if someone's made it public. Timing is also really good online, not as good as the desktop. No one will ever have timing as good as in the desktop. So you're seeing here variabilities for most packages in the region of 5 to 10 milliseconds, or slightly faster in PsychoPy's case, but very relatively good. Audio presentations are a bit slower and a bit more variable at the moment online, but and that's for all packages. But again, all of the data for that are available in our preprint. Now, the other thing where we're slightly different is that we are in, so PsychoPy is open source. It's been open source since 2002, but we're now funded, and we're now using micropayments via pavlovia.org. So this website, if you run studies online, you pay for credits, or you get your institution to buy a site license, and that's now funding the further development of PsychoPy, PsychoJS, and other packages like JS Psych. If you're using pavlovia.org with JS Psych, then we'll give that money back to JS Psych. The idea here is that we're using very small payments, so £1,500 for the entire institution for as many users and studies as they like. And, think of it as encouraging your university to support open source software. We're using that money entirely to build these packages and make them better. Okay, so our unique selling points, I would say unprecedented flexibility in our stimulus and response options, the ability to run both in the lab and online with as good precision as any have, and better with the online options as far as I know, an actual textbook and a business model that allows it to be really highly supported with professional but still open source code. Thank you to the many people who've contributed to our project down the years in terms of code, forum and funding. And thank you, Candice.
Thanks very much for that, Jon. Okay, so next up is Claudia von Bastian with Tatool. Claudia, will you share your content? Oh, there we go. I see it. All right. Okay, so here's Claudia von Bastian with Tatool. One moment. Okay, unmute yourself though.
Okay, classic. So hello everyone, and welcome also from my side to this part of the webinar, and thanks to Candice for organizing this. This is really great. So I'll give you just a quick high-level overview over Tatool and some pointers to where you can find more resources and help and support if you need any. So what is Tatool? Tatool is a comprehensive open source experiment software that covers the entire life cycle of an experiment. So that means that you can develop your own tasks and configure test batteries. As OpenSesame and PsychoPy, you have the full range of possibilities, really, what you can do for your experiments. But then you can also distribute them automatically with Tatool. So you can make your experiment or study available with just a click of a button, really. You can then collect your data by administering your tasks in any modern web browser, and then closely monitor that data collection and access your data immediately in a CSV format that is really handy for doing your analysis in any kind of usual statistics package. What we really like about Tatool is that it's super flexible, so you can either just reuse and tweak some existing tasks, or you can develop your own super unique and novel paradigms. On the one end of this range, we have the experiment editor, where you can create an experiment based on the existing tasks, and you can do lots of different tweaks so that the existing tasks can fit many purposes of experiments. So for example, you can change instructions and stimuli, you can change the timings, you can switch on or off certain features of the different tasks, and so on. And you can do all of that without having to code anything at all. If, however, you want to develop some new tasks or do some more substantial changes to existing tasks, you can use Tatool Web's JavaScript-based framework that enables really fast coding. So it's pretty straightforward once you get into it. You can also run your experiments online and offline. And now at the moment, we are all seeking for the online solution, but assuming that at some point we'll be able to go back to our physical lab spaces, you can run the exact same experiments easily also in your offline environment. And another aspect of this flexibility is because you can run your experiments on any device that have a web browser, you can run them on any computers, tablets, smartphones, and so on. So for example, just recently we ran an experience sampling study with cognitive tasks on smartphones that ran really smoothly. You could also think of administering your tasks on a tablet, for example, in a hospital setting with patients or so. So you just have all the possibilities open to you, whatever you need for your specific research. And one pillar that is not specific to Tatool, but to all open source software is, I guess, that it's really important to us that we contribute to improving the reproducibility of research, but also global access to research tools that are free. And we do so by, of course, providing Tatool open source and freely available for anyone to use, but also by encouraging our users to share the materials, for example, on our task library, but also on platforms like OSF. We hope that helps to make research a little bit more independent. So here we provide Tatool or access to this research tool globally and funding independent of any funding for anyone and anywhere. The technologies Tatool is based on are JavaScript and HTML5 and CSS for the task functionality and appearance. So you don't have to be a JavaScript expert, even if you want to get into the programming of your own tasks with Tatool. I would still recommend that you run through some basic JavaScript tutorial first and then start with programming in Tatool. For those of you who are interested in how the backend works, that runs on Node.js with a MongoDB. How can you use Tatool? There are pretty much two options. The first option is you can run your experiments via our web server on tatool.com, which is based in Switzerland for those of you who are concerned over GDPR issues. And to do so, you have to register on our website with developer access. And then once you did that, you can create and edit your own experiments, and you can start collecting and downloading data right away. I just recently created an introductory video that goes through this whole process from A to Z, really. So from getting your developer access down to running your experiment and then downloading your data and looking at the different columns of the output and making sense of them. So have a look at that video if you're interested in how this works specifically. Also, if you would develop your own task or have study-specific materials that you want to run through our web server, we are very happy to host your tasks. And we do so for free if you're happy to share them with others. So this is part of us encouraging that sharing amongst users as well. This option allows only for online research, and the distribution of your experiments will also be through a URL. If you want to do also offline research in the future, or create your own tasks, or get into the programming bit of it, then you'll have to set up a local instance for this full flexibility. That means you have to download Tatool Web, the software, so to speak, itself, and install it on your own computer. And that means you will have to get into some more details there. We have like a getting started guide there on our documentation. So when you go through that step by step, this is a really straightforward process. What that means then, what you will get in addition to all of what you get with option 1 is, of course, you can develop your own tasks then and whatever extensions you like to Tatool. So all of it is open. So whatever you want to change about it, you can. You can then also manage users and projects in your own environment. And of course, you can then also actually host your own web application if you like to. So you can have your own tatoolweb.com for your university, for example, or your lab. If you want to do that, this is slightly more complex, but just get in touch with us and we can give you some good pointers to how to do this in the smoothest way possible. If you do that, you can do online, offline research with exactly the same tasks, environments, and whatever else. So I just wanted to show you a very quick example of a simple task. So this is how it looks like for participants. They will usually get some link from you. They click on it, and let's see whether that now works. It doesn't open my browser now, of course. Let me see. Worked every single time when we tested it before. Okay, so now it worked. Okay, so what you will see, or what your participants will see then is some title of the experiment that you chose yourself. They then press the start button. Everything, all the contents are loaded before the actual experiment starts, so that you don't have any problems with internet connection lags or whatever. And the actual experiment then runs locally on the machine of the user. In the beginning, they see some instruction. You can use pictures, whatever you like here. And then, for example, we might have a countdown that counts down in the beginning. This is, again, a feature that you can turn on or off as you please. In this task, we show some centrally displayed stimulus to which we have to respond fairly quickly. We show a response timer for this purpose. You can, again, just switch that off if you like. You have to respond via buttons. You can also use just keyboard instead. We have a trial counter here. We provide some feedback as well. So for example, now to give some positive feedback. And if you have a training task that is adaptive to performance, for example, you can also show the level if you like. So all of these things here in the status panel, this is how this is called, the top part, can be switched on, switched off, depending on your needs. Once the experiment is finished, all the data is upload it to our server, and then you can immediately access it and use it for analysis, monitor, data collection, and so on. Your participants will get like this unique session token here that they can then share with you for whatever compensation you might have, or prize draws, or whatever means of recruitment you use. Okay, let's see. Yeah, I get back. We have lots of other examples for different tasks. So if you're interested, have a look at our task library and check out the demos there. So just click on whatever paradigm you might be interested in and have a look at the task. So one thing that I just also wanted to mention is that Tatool is entirely nonprofit and community-based, so any contributions are highly welcome. So for example, we have lots of translated instructions for different tasks, or if you have specific stimuli that you use for your particular task or your particular study, or if you have entire test batteries that you think could be useful for anyone else, we are very happy to share them on our website as well to give them some more visibility. Also, if you developed any extensions or components for the framework, please get in touch. This is an open source project, so you're very welcome to contribute to that as well. And if you have really any ideas for features or any feedback, we always love to hear from you, so just let us know. And just for some more resources and some support, so to get started, I put together a list of links here, and we'll share those slides later on, so you can just click through if you like. So I would start maybe with going over the glossary just to get some ideas of what we mean by executables and modules, for example. Then you can have a look here at using Tatool Web. This is for doing the web server version, the first option, and that also contains the detailed video for how to go about this. The FAQ is also worth a look. If you want to go into the programming part, we have a tutorial for development as well. So have a look here for learning how to program your first own task. In this example, this is a flanker task. And we have a documentation, of course, with reference to all the functions included in Tatool. If you want to get in touch, please do so. You can report bugs or ask any questions you have on our GitHub page. Also get in touch, of course, through email or Twitter. Yeah, so that's from my side. Thank you very much, Candice, for organizing this, and for everyone for watching.
Great. Thanks very much, Claudia. Okay, so we've got a lot of attendees here and a lot of questions have been asked. And so I've been working on trying to compile popular questions, also to think about the questions that I think are so general that lots of people will want to know the answers to them. So we'll spend like the next 15 minutes in Q&A. You can continue to ask questions in the Q&A channel if you like, but I've got a few rising to the sort of top of priority. I'd also like to emphasize, if we don't get to the specific question that you asked today, that each of the presenters has a very nice online presence. They've highlighted in their presentation ways that you can go on to forums and facts to find out answers to specific questions that I suspect some of the questions you've asked are available in these online resources. So I want to focus on some of the most general things. Let me start with questions about security. So there have been a few questions about this. I'll just kind of lump together what I think are some important points that people are going to want to know as they try to push studies online. So one is, in all platforms, is there anything to prevent participants running the same experiment multiple times?
That's typically something.
Hang on, let me send you live, John. Sorry, here you go. All right.
That's typically something that would be handled by the recruitment system, and I mean, certainly Pavlovia and Think Yatos as well. You know, we don't handle the recruitment side. That would normally be done through MTurk and Prolific. So Prolific have a system that prevents people redoing the experiment. I mean, you could insert something into your study that says, has this participant ID been used before? But typically this is something that you would handle through the recruitment tools instead.
Okay, so I'm gathering So I'm gathering from this that it's not putting a study online is not only about programming it to work in a browser. It's also about having some kind of system in place for participants to sign up and interact with the study.
Yeah, I mean, there are different things. You can email around the URL to people for sure, and then you would need to handle your own aspect of, you know, inserting something to prevent people running more than once. But most people, I'm saying, are using something like Prolific, Sonar, Mechanical Turk, and all of these three packages allow you to connect with those. So yeah, that's often an additional step that you would then use another system in order to bring your, so, you know, Prolific has thousands, tens of thousands of workers ready to come and start doing your study, and they will send them your way. Certainly we don't have any intent to start doing that side of things as well.
Mm-hmm.
Can I add something to that?
Yes. Okay, Claudia, you're live.
Yes. So the same goes for Tatool Web, and I assume OpenSesame probably as well. One thing that Tatool Web has in addition is that you can either use the URL and just distribute the link to your experiment, or you can invite users directly only to your experiment. Usually in most cases, it's probably easier to set something up as what Jon alluded to. But if you have a specific sample that you want to use and you want to make sure they do the experiment only once or maybe twice, or they do a training study or something like that, for example, then you can also use adding specific participants to your experiment only on Tatool Web.
Can I also say something about that?
Yes, Sebastian, you're alive.
All right, so actually Yatos, the server-side component for that OpenSesame uses, OS Web, does actually provide a way to have those kinds of restrictions. So I will very briefly show it. It has the concept of workers. So if you go to a study, I click here on study, you have a worker and batch manager. You can all find all of this documentation online, right? I just want to convey the general idea. And there you have what they call workers, and each of the workers is associated with a different rule for when a participant is allowed to do it, etc. So for example, a personal single worker would be a link that you send to someone and only that person can do it once. A personal multiple worker, you would send that to someone and that one person can do it multiple times, but other people cannot. Right, that's based on cookies, I think. Yatos is not our project, right? I'm just describing how this works. And the general multiple worker is the link that is very unrestrained and everyone can do it as often as they want. But basically, Yatos does actually provide control over who does which experiment and how many times. And that is actually, I think, quite important and quite convenient also. So, all right, that's it.
Okay. All right. So another important thing, probably not the most exciting topic of discussion, but really important, especially for those of us working in Europe, subject to GDPR regulations, the protections that are in place when you're working online for participants' data remaining confidential. I assume that this is all done on the server side, so it's not necessarily under the control of the software that's being used. Any comments on this?
I can comment on it very briefly if you want.
Hang on, I'll send you live.
All right. So the Yatos is something that the institutions would, generally speaking, install themselves. So they would install the server software on their own institutional computers, and as such, they would have full control over the data. That is convenient from a GDPR perspective. It's inconvenient, clearly, from the perspective of individual users who might not have access to a Yatos server, but it is from a data privacy perspective quite convenient.
Okay.
Well, I can add more if you want on ours, yeah.
Sure, sending you live. You're live, Jon.
So on Pavlovia, it operates on a server currently in the UK. And the idea there, we're kind of thinking that actually setting up a server and getting the security right is hard and really secure, with control over the ciphers that you use and that sort of thing. And we think it's probably better to provide that for you than have people set up their own servers. So that's Pavlovia is built around that idea that you push to a server. It is all GDPR compliant. It's super secure, and it's still up to the experiment runner, the designer, still needs to know about what they're collecting from their participants, right? So it's still up to that designer to know not to harvest people's emails without their permission and that sort of thing. You know, they're still in control. But in terms of security, yeah, by having our own production level servers in super secure data centers is we think the sort of safest place.
Okay.
I can say how that works in Tatool as well. Like.
Okay. All right, Claudia, how does it work in Tatool?
So in Tatool, it's similar to OpenSesame. You can set up your own server if you like, and then your own rules apply, kind of. If it is about the location of the web server, that is in Switzerland. So if you need a Europe-based server, that should do it. If you have very specific questions, you can get in touch with us, and I'll be happy to talk about the nitty-gritty details as well.
Okay, let's see. All right, let's move on to something else. So one thing that I gathered, learned, I've got a little bit of experience with each of these platforms, but for the time being, I'm mainly a Python user. I've not actually done a lot of online data collection. But what I'm gathering from the way things work is that once you go online, you need to be using JavaScript. I assume that that's really important since the Python-based programs, OpenSesame and PsychoPy, both convert to JavaScript in the online versions. If we're planning to run online, why not just cut the middleman and use a JavaScript version?
So can I comment on that?
Yep.
So you're saying that.
Hold on, you're live now, Sebastian. Okay.
So just to clarify how each of these, so OpenSesame doesn't convert to JavaScript or convert to Python. It is actually a JavaScript library, OS Web, when you run it on the browser. So basically what you applied, why not just implement it in JavaScript? It is implemented in JavaScript. What is still implemented in Python is the desktop GUI to build the experiment, so to say. But as soon as you go to the web, all of that is JavaScript, and it has to be because JavaScript is the language of the browser.
Okay. Anyone else have comments?
Yes.
Okay. John is live in a minute. Okay, here's John.
So yeah, the way it works with PsychoPy, I saw a couple of other comments there about, you know, can there's one about can we just do all of the JavaScript manually, and like, yeah, you can write that manually, and you know, Sebastian, with OpenSesame, you can insert code snippets, but they need to be code snippets written in the right language. So with PsychoPy, in the builder, which is what I would recommend, rather than handwriting your script in Python, you know, it's that builder can generate both formats. If you've got code components, it will actually translate those, but the main experiment isn't being translated. It's being generated from an abstraction into both formats. That's kind of the way it works. If you're only planning to run online, yes, you could just learn JavaScript and start from scratch. You know, it's just inefficient, right? Builder allows you to do it once and generate both formats.
Mm-hmm. Any other comments about this before we move on?
I guess I should say something as well.
Okay. All right, Claudia, you're live.
So in Tatool Web, of course, it's all based on JavaScript, and yeah, this is what you would do. So either you use the experiment editor without any coding, or you use that and write your own experiments in JavaScript. But what Tatool Web provides you for that is a library full of functions and a framework for how to do your tasks and how to code them. So it's pretty straightforward, I think.
Okay. All right, so we'll be wrapping up soon. I just want to emphasize there have been a lot of specific questions about representing fonts and stimulus size and RT, some of which have been covered in presentations. And I think that, well, I know that the presenters all have access to this Q&A, and so can go on social media and point you to the resources that are needed. I think the one final thing that I want to find out, if any of the presenters have some insight or experience about, is what do we do running experiments online, sort of make sure participants behave? How we can wrap this up into a little bit more of the technological ways of managing this too. So what is the best practice for ensuring that individual internet speeds, computers, monitors, browser use doesn't interfere with the integrity of data collection? And do you know of any good practices to make sure that you can tell that participants actually do what you ask them to do?
Can I comment on that briefly?
Just a moment, I'll send you live.
Mm-hmm.
There you go. Sebastian's live.
I think my main advice would be to be realistic in what you can expect online, and not try to force online experiments that are uncontrolled into some kind of controlled lab environment, which you will not get, right? So try to modify your experiment so that it fits what people are used to doing online, which is something short, right? Not an hour and a half of psychophysics, but maybe 10 minutes of clicking a few buttons. They might make it through those 10 minutes, although that's already a lot, huh? 10 minutes without checking WhatsApp or whatever. So and also in terms of precision, etc., and just accept the fact that you will not really have that to the extent that you will have it in the lab, and make your experiments in such a way that you don't make that assumption. I think that will be the best design. If you want to do extreme precise psychophysics, don't do it online. Do it in a lab. But for most experiments that you actually don't really need that level of precision, and just collecting a lot of data, for example, which you can do online, will give you much higher statistical power, for example, and a little bit of precision that you lose in some respects is not really that important quite often. But it depends on your experiment, and just be realistic. That will be my main message.
Okay. Anyone else want to comment about this? No?
No, absolutely.
Fine. Oh,
Okay.
sorry.
All right, I'll come back on then. Okay, thanks everyone for your insight. I've learned a lot from this. I've personally not really thought much about collecting data online before, but I might consider it now in the future. And now I've got a lot of ideas about ways that I might do that. Let me just say that in closing, the Journal of Cognition, the journal that I edit, is fully open access and committed to research transparency. And one of the things that we encourage actually is the publication of experimental resources. So we welcome actually papers that are written specifically to promote well-developed software for collecting data on useful experimental tasks. So we expect that researchers who might want to publicize a particular paradigm that they've created an open source program for, who want to promote their tasks in these manner by writing a paper about them, have put maybe some extra effort into usability compared to what you might do for your own private use only, like making your program easily editable for changing aspects of your task, ensuring that naive users can understand the resources that you're providing, things like that. So I encourage you, especially right now when it might be difficult to get the data that you really want to get, but you've got lots of time to plan studies. If you're working on creating a popular cognitive task using one of these open source experiment builders like OpenSesame, PsychoPy, or Tatool, why not consider creating a flexible, user-friendly version that you could widely share and promote via publication in the Journal of Cognition? It'd be really cool to build a collection of openly available experimental resources for cognitive psychologists and have some system for disseminating this collection widely. So if that sounds interesting to you, please feel free to get in touch with me. You can find my contact information via the Journal of Cognition's website. And we can discuss if you're interested in publishing about your software with us. I can advise about the supportive resources that I think would be useful to include, and potentially on the possibility of fee waivers if we go about building a special collection devoted to experimental resources. I'm going to close this session. I think the I'll close the live video part of it, but I won't actually end or I will try, actually, I'm not sure how this works, not to end the session exactly, so that if there's any questions that are currently being answered by any of the presenters, they can go ahead and do that. But I've also compiled a list of the questions that you've asked, and I can make sure that that's available to all the presenters in case they want to address any of these things on social media accounts. So I'd like to thank all of you very much for attending, and to thank Sebastian, Jon, and Claudia for being with us today. Good luck with your research, and can't wait to see what you share with the world.